So right, pressure P1 equal to 10 bar, dry and saturated. So X1 equals to 1. What is the back pressure P3? 1.5 bar. If it is dry and saturated, is the value of N is 1.135. From this, can we calculate pressure P2 by P1 equal to 2 upon N plus the power N upon N minus 1. This ratio is fixed. Is it 0.577? So if you put P1 equal to 10 bar, is P2 equals to 5.7. So we'll approximate to 5.8 bar. Is it a loss is 10%? Loss is 10% means efficiency is what? 90%. And is the loss it takes place in divergent only? Loss takes place in divergent only. Means convergent is what? Smooth. This one is HS diagram. We have 3 pressure line. First is 10 bar. Second is 5.8 bar. Third is 1.5 bar. This one is ideal process. The loss. So this one is 3 dash. 1 to 2 is ideal. Pressure, is it 10 bar? So see here this line, this is 10 bar line. 10 bar and this one is dry and saturated line 100%. This is your point number 1. Mark your point number 1. Check enthalpy at this point. Okay, check. Do you have 5 bar line here? 5 bar line. Then 5 bar and 10 bar. There are 5 lines. So your 5.8 is very close to the first line. Do you have 5 bar line? This one is 5 bar line. This one is 10 bar line. Between 5 bar and 10 bar, there are 5 lines. Means each line represents 6, 7, 8, 9. 5.8 is very close to 6. So very first thing, you draw vertical through this line. Vertical through point number 1. 5.8 is very close to this. Now record this point. I will write approximately 2670. What is the back pressure? Is the back pressure is 1.5? Back pressure is 1.5. So record 1.5. 1.5 is here. So this line, 1.5 line. 1.5 line is this. Line if it is not intersecting. So look at this point. What is the corresponding enthalpy at this point? What is the value recorded? We have H1. Is it 2450? Nozzle efficiency equals to H1 minus H3 dash upon H1 minus H3. Confirm in the problem that the inlet velocity is negligible. Inlet velocity is what is V3 for ideal case? You have to compare two values, one with the ideal, one with the friction. Under root of 2 times H1 minus H3 multiplied. 812 meter per second. Okay. Write actual velocity V3 dash under root of 2 times H1 minus multiplied by 1000 for kilojoules. You are asked to find out first final velocity, that is the first answer. So this one is answer 1. Second one, you have to find out percent reduction in final velocity. That equals to V3 dash minus V3 upon V3 equals to 770 minus 812 upon 812 multiplied by 100. Answer is minus the problem. The throat diameter of a convergent divergent nozzle is what? 12 mm. So write D2. The steam at 10 bar, P1 equals to 10 bar. Corresponding condition is 2 to 5. Treated. Then N equals to what? 1.3. Enters the nozzle and is discharged. Discharge is back pressure. 1.5 bar. All pressure are always absolute. You want to calculate m dot, mass flow rate. Assuming that the loss section only. What is the nozzle efficiency given to you? 90%. So P2 is approximated as 5.4 bar. For calculation purpose, we'll take it 5.5 bar to locate on Mollier diagram. If you are available with 5.4, we'll go for 5.4. If the flow in a convergent is a smooth, so 1 to 2 will be like this. What is the friction is occurring? So this one is 3 dash. This is Mollier diagram. Mollier. This one is 10 bar line. Now this temperature is 200. Can you see 200? Can you see 2 to 50? Two lines we have got. One is 200, one is 250. This one is 200 line. This one is 250 line. This one is 10 bar line. Is your point between 200 and 225? So approximately draw this 2 to 5. Look at your point 1. Enthalpy is very close to 2900. We'll make it 2890. 1, you draw vertical line first. Draw approximately 5.5 line. Let cut intersect vertical line. Take your enthalpy equal to what? 2780. Look at your 1.5 bar line. See here 1.5 here. This is your point number 3. Look at your enthalpy at point number 3. Is somewhat very close to 2540. This time we will not going to calculate 3 dash. Remember, we will prepare the solution, professional solution. What I want, m dot. Can I calculate m dot equals multiplied by V2 multiplied by small v2. So I need to calculate only v2 and specific volume. Now go back to the Mollier diagram first. The point number 2, is it superheat region? Point number 2, is it superheat region? Back to figure, Mollier diagram. Is point number 2 is superheat region, and is this temperature is approximately equals to, see the temperature line. This temperature line is what? 150? This is 150. This one is 100. So I think this is very close to what? Check this line. Is it more than 150? So let's guess this value equals to what? So this temperature is 160. So your dome shape will be like this. Dome shape will be like this. Is 3 is inside the set 2. P2 equals to 5.4. T2 equals to T sub 160. This is superheated. So what is V2? V2 is Vg into T sub divided by T sach. Temperature is Kelvin. So plus 273 at 5.4 bar. Open your steam table. See 5.4. Substitute this value and find out V2 first. So this value is T sach and this value equals to what? Only two value at 5.4. So Vg is 0.348 and Tsat is 154.8. From this calculate V2. V2 equals to under root of 2 times H1 minus H2 multiplied by 1000 equals to, next is m dot. Put this value back and find out m dot. Area is pi by 4. Diameter is 12. Velocity is 509 divided by specific volume is 0.3535.